Hello, and welcome to our webinar series on beginner ICT networking. I'm Benji, and I'm thrilled to have you here. In this exciting series, we're going to embark on a journey into the world of ICT networking. So whether you're a curious enthusiast or an aspiring IT professional, get ready to unravel the secrets behind how our digital world stays connected. Let's dive in. Networking is the invisible force that powers our digital lives. It's what allows us to connect with friends and family across the globe, access information instantaneously, and tap into the vast resources of the internet. Without networking, our digital experiences would be limited and isolated. Imagine a web of interconnected devices, each one communicating, sharing data, and working together seamlessly. That's the magic of ICT networking. It's the art and the science of building pathways and bridges between devices, enabling them to exchange information and collaborate in ways that shape our modern world. Now, you might be wondering, what exactly is ICT? Well, ICT stands for Information and Communications Technology. It's an encompassing term that refers to the technologies and systems we use to process, transmit, and manage information. At the heart of ICT lies networking, the backbone that allows these technologies to connect and communicate with each other. Think of networking as the language that devices speak to understand each other. Just as we use words and gestures to convey our thoughts and ideas, devices rely on networking protocols and languages to exchange data. Whether it's sending an email, streaming a video, or conducting an online meeting, networking is the invisible force behind these interactions. To facilitate this communication, we rely on an array of network components. These components act as the building blocks of networks, allowing devices to connect, share resources, and transmit data. Routers, switches, modems, and cables are among the key players that come together to form the intricate web of connections that we rely on every single day. Throughout this series, we'll unravel the mysteries behind these network components, exploring their functions, configurations, and how they work in harmony to enable seamless communication. But before we dive into the nitty-gritty of network components, we need to grasp some fundamental concepts, and that's where IP addresses come into play. IP stands for Internet Protocol. An IP address is a unique numerical identifier assigned to each device on a network. It's like a digital street address that allows devices to find and communicate with each other. Understanding IP addressing is crucial as it forms the foundation of networking configurations and the very fabric of how devices connect in the digital realm. In addition to IP addresses, we'll also explore the concept of subnetting. Subnetting is a technique that allows us to divide a large network into smaller subnetworks, enhancing efficiency and management. It's like dividing a big city into neighborhoods for better organization and control. In the next episode, we'll go further into IP addresses, explaining their significance in networking, the distinction between IP4 and IP6 addresses, and how to identify and assign IP addresses. But for now, let's move on to network components. Let's start by discussing one of the most fundamental network components, routers. Routers act as traffic directors within a network. They receive data packets from one device and determine the most efficient path for those packets to travel to reach their destination. Routers connect different networks together, allowing devices to communicate beyond their local network. Next, we have switches. Switches are like traffic managers within a local network, such as a home or office. They receive data packets and forward them directly to the intended recipient within the same network. Switches create pathways within the network, enabling devices to communicate with each other seamlessly. Another important network component, not to be overlooked, is the modem. The modem serves as the bridge between your local network and the wider internet. They connect your network to the internet service provider and facilitate the transmission of data to and from the internet. Modems often provide both wired and wireless connectivity options, allowing devices to access the internet. In addition to routers, switches and modems, there are other network components that play specific roles. For example, firewalls provide network security by monitoring and controlling incoming and outgoing network traffic. They act as a barrier between your network and potential threats from the internet. As this is just the introduction to networking, we'll leave some of the more advanced networking components till a little later in the series. While we're talking about network components, we can't forget network cables. Network cables are also vital components that physically connect devices within a network. Ethernet cables, for instance, enable high-speed data transmission between devices and network components. They ensure reliable and stable connections, forming the backbone of wired networks. Now, let's have a quick recap of the network components that we discussed today. Routers direct traffic between networks. Switches manage local network traffic. Modems connect your network to the internet. Firewalls provide network security, and network cables physically connect devices. During the information we've learned so far, you may have heard a distinction between a local network and a wider area network. These are two very important distinctions in networking, and we're going to dive into them right now. First, let's talk about LAN, which stands for Local Area Network. A LAN is a network that covers a limited geographical area, such as a home, office building, or school campus. It connects devices within a close proximity, allowing them to communicate and share resources, such as files, printers, and internet access. In a LAN, devices are typically interconnected using wired or wireless connections, such as Ethernet cables or Wi-Fi. LANs offer high-speed communication and are commonly used for internal network needs within a specific location. Now, let's shift our focus to WAN, which stands for Wide Area Network. A WAN is a network that spans a large geographical area, often connecting multiple LANs together. WANs can cover vast distances such as entire cities, countries, or even continents. WANs use various technologies, including dedicated leased lines, satellite links, or even the internet to connect different LANs and enable data transmission between them. WANs allow organizations to establish connections between their branch offices, connect to remote servers, or access resources hosted in different locations. Unlike LANs, which are typically owned and controlled by a single organization or user, WANs are often maintained by telecommunication companies or internet service providers. WANs provide a means of extending network connectivity beyond the boundaries of a local area. In summary, a LAN is a local network that covers a small area and connects devices within close proximity, while a WAN is a wide network that spans large distances and connects multiple LANs together. LANs are ideal for internal network needs, while WANs facilitate communication and data exchange between geographically separated locations. Understanding the distinction between LAN and WAN is crucial for designing and managing networks, as it helps determine the appropriate network infrastructure and connectivity options for specific requirements. Before we wrap up this episode, let's test your knowledge with a quick question. Which network component connects your local network to the internet? Take a moment now to think about your answer. The correct answer is modem. As we discussed, modems serve as the gateway between your local network and the internet, allowing devices to access online resources. Great job if you answered correctly, and if not, don't worry. Learning networking is a difficult facet of ICT, and it takes time and practice. That now wraps up our introduction to ICT networking. In the next episode, we'll look more closely at IP addresses, specifically what IP addresses are, how IP addresses are made, the distinction between IPv4 and IPv6, and much, much more. Also, if you have any questions about this video or any subjects at all that actually interest you about networking, please feel free to leave them in a comment below. We'd love to hear from you. Thank you so much for watching, and we'll see you in the next episode.